Assalamu alaikum. So in this problem we are given two integers n and k. Here n is the size of permutation and k belongs to a given condition. The condition is among the sums of contiguous segments of length k, any two sums differ by no more than one. That means if we take any segment of length k from this permutation and any another segment of length k from the same permutation, the sum, the difference of sum of these segments should be less than or equal to 1. Okay, now how to do it? Let's say n is 10 and k is 4. So the answer was this. It is 1, 8, 4, 10, 2, 7, 5, 9, 3, 6. Okay, so the value of k here is 4. So if we consider this segment, let's say here the sum is sum. Okay, now if we consider this segment, we can see that uh, here these three elements are the same. The only difference is that here the another element is 2, but here it was 1. So here another element has increased, so sum must increase by 1. So here sum is sum plus 1. Now if we consider this segment, these three elements are the same. Only difference is in this element. Here it was 8, but here it is 7 if we consider this 4. Okay, so sum will decrease by 1. So here it was sum plus 1 and here it will become sum. Again, if we see this portion, previously we are in this portion. Okay, now we are considering this portion. So here it was 4 and here it became 5 and the rest of the elements are the same. So sum again increased by 1. So here sum will become sum plus 1. So we can see that by this way the sum is always sum or sum plus 1. So if we randomly take any segments of k size, any two segments of k size, their some difference of summation will not exceed 1. Okay, now if we try to see it uh, more properly how it is working, here n equals 10. So we have 10 elements: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, now 1, 8, 4, 10. So 1, 8, 4, 10. This is the initial segment. Okay, now we have seen that 1 always increases. So 1 will always increase, 8 always decreases, 8 will always decrease, 4 will always increase, 10 will always decrease. So after that, here we will get 2 in this position. Okay, and 8, here we will get 7, it decreased. Then we will get 5, it increased. Then we will get 9, it decreased. then we will again get 3. It increased, then we will get 6. It decreased. Okay, so this way, if we can select the initial k elements properly, then we will only increase. Okay, as k equals 4, it depends on this element. It depends on 4 elements previous element. Okay, we only increase the the odd section and decrease the even section. For any odd position, the value will become, and let's say we are in ith position. Answer I is equals answer of I minus k plus 1, and for even position it will become minus 1. Okay, and now how will we select these k positions? Let's see it. Okay, if we again consider the same example, 1 2 3 4 5 6 7 8 9 10. So as we have k equals 4, so we will have initial 4 elements. Now the number of steps for each initial element equals n by k. That means 10 by 4, and it is true. Okay, if we consider 2 steps for each of the initial 4 elements, then the total step is 8. But there is also 2 extra steps. So the extra steps is 10 mod 4, and it is 2. So some uh, positive or plus which we are increasing. Let's say this is, this will always increase, this will decrease, this will increase, this will decrease. Okay, some positive uh, part will have extra 1, and some negative part will also have extra 1. That means let's say the element of this position. Okay, initially we are considering that all these elements will have 2 steps, but as we have 2 extra steps to, so we will add 1 extra in this position and 1 extra in this position. So finally it will have 3 steps, it will have 3 steps, it will have 2 steps, it will have 2 steps. Okay, now we start with 1. We are keeping 1 here, as this another position positive part has 2 steps. So this first of all, this one, this first position has 3 steps, so we will go 3 steps from here. So 4 will be here, and now as this has this 4, it has 2 steps, so we are considering 2 steps here. Okay, and as the negative one has 3 steps, we are considering 3 steps from here. Okay, so it will cover 2 steps and it will cover three steps. So 8 here, 8 will be here. Okay. Now we have considered 8. Okay. Again, the final value will be 10. Okay. So what will happen? 1, 8, 4, 10. 1, 8, 4, 10. The next value will be 2 increased. The next value will be 7 decreased. The next value will be 5 increased. The next value will be 9 decreased. Again, the next value will be 3 increased. The next value will be 6 decreased. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 values. So how can we do it on code? Let's see it. Okay. So first of all, we are taking the test cases, then the value of n and k, then we are taking steps and extras. Now, if extra becomes 3, suppose extra is 3, extra is 3, our first position value is always increases, and second value always decreases, third value always increases. So we, whatever the case, we need to distribute in it in distribute the extras in first sum values. Okay. So the positive will get, so there is two positives, so, and one negative for to contribute in this extras. Okay. So we have done this. Now we are only considering the positive ones. Here we are only considering the negative ones. In this portion, we have developed the first k elements. Then, based on these first k elements, we can develop the rest. Okay. Finally, we print the array. Thank you.